Good morning, this is Jerry Frost. Hennepin Technical College, we've got Advanced PLC, and this is lesson Pneumatic PLC 4. I will go through three sequences here. First, I'll show you with this short description and this chart, just a quick and dirty of how this timer, counter, and comparison works. Then I will, in detail, go through the steps of what happens in the program. Then I'll get into the actual program with it running, and we'll just see it operate. So to start with, as you see here, we're basically going to have, when a push button is pressed, a lamp will turn on, and a timer will start timing. When it reaches effectively the fifth cycle, we're going to, through a comparison, turn on a lamp 2, and we're going to continue to turn this lamp on and off multiple times. When it reaches the 10th count on a counter, then we are going to reset this whole process, and it will start the process back over. So let's look at a little more detail here at what's going on in this program. Push button 1 is pressed and a work bit is latched. Rung 2, when the work bit becomes true and timer 4.1 is not done, the first of the two timers starts, timer 4. Rung 3, when the timer 4 done bit is true, it's 3 seconds, and the work bit is true, timer 4.1 starts. Then we look at rung 4, timer 4 done bit becomes true, the counter increments by 1. Rung 6, timer 4 done bit is true, and the work bit, of course, is still latched, so the lamp turns on. On rung 2, when timer 4 done bit becomes true, and 3 seconds have passed, the not done instruction is false. This causes timer 4 0 to turn off. Rung 3, timer 4 done bit is false now. This causes timer 4.1 to reset. The done bit turns to 0. Rung 6, timer 4 done bit is not true, and the lamp L1 turns off. So we wrap around to the next cycle, rung 2, timer 4.1 done is not done. So the instruction is true. Timer 4 once again starts counting again. When we look at the actual program, we'll see what's happening is these two, timer 4 goes through, its done bit becomes done, timer 4.1 starts up, and when its done bit changes, timer 4 is reset again. So, as you can see, I've taken the various instructions all the way down. Let's take rung 7. When counter 5 accumulate gets greater than 4, and the work bit's still true, the lamp 2 will turn on. And finally, in rung 4, when counter counts up to 10, the counter 5 done bit is true, and up at the top of the program, rung 1, the counter 5 done bit, it causes the done bit become true, and we unlatch the work bit, which restarts the whole process. So let's enable this. Here you see I have what I call PLC on a knee, and I will zoom out a little bit. I don't think I will be able to zoom out a little bit, but we'll get this program working. Here we have timer 4.0 counted up, timer 4.1 counts up, and every time timer 4 done becomes true, we increment this counter. Let's quick scroll down. Watch this lamp here. Accumulates 4, accumulates 5. We just became true here on lamp 2. Now we have to continue toggling through these two timers until our accumulate gets up to 10. At the time that 10 is achieved on here, this done bit will become true and will unlatch the work bit and reset the whole process. Here we are at 8, 9, this is still false. Watch what happens when we reach. It pulses, you're not able to see it, it's very quick. done bit becomes true, we unlatch and we start. It's almost effectively like an electronic oscillator circuit in the two timers. And here is the PLC with lamp 1 actually. Watch lamp 2 in a second here. When our comparison becomes larger than, there we go, lamp 2 turns on because the comparison became greater than 4. So that's effectively how our whole process works, using a pair of timers, a counter, and a comparison, basically a greater than instruction, using 2 lamps.